As we saw, Python is an object-oriented programming. Now, once again, if I just take an example of object, okay, I'll consider a real-time example of an object. It can we can consider your email, okay, that can be represented as an object. If I want to just tell what are the properties of your email and the behavior, the properties of the email can be considered as the recipients list, the subject and the body, and the behaviors for an example can be considered as adding the attachments and sending. Fine. So whatever the real world things are there or existing, we can consider them as what? That is objects. And once again, coming to this object oriented programming, fine. So more of understanding is required whenever we want to learn the concepts of object oriented programming, and Python is an object oriented programming language. Okay, all the concepts of object oriented programming is incorporated in the Python language. And once again, if I just consider some of the advantages of this object oriented programming, the code reuse and recycling can be done. There will be an improvement in software development productivity as well as maintainability, faster development of the program, and lower cost and high quality softwares can be generated by using the object oriented programming concepts. And disadvantages, definitely this could lead to large programs sizes, and more of understanding is required before we take up any project. And coming and once again developing that project by using the concepts of object oriented programming. And basically, whenever we consider object oriented programming, the use of object oriented programming concepts is good in complex projects or in the systems that are of modular types. It is nothing but whenever we are developing a project in terms of modules, okay, it is always better to go with using the concepts of the object oriented programming. Now you can see here, okay, a class is the basis of any object oriented programming language. We'll see what is a class, fine, and what is an object and why actually the class with respect to the object oriented programming. Now moving to the next, a class is a user defined data type which binds data and functions. Your data here, it is nothing but the properties or the attributes or the variables, and the functions, they are nothing but the methods or the behavior that I have told just now. Now, before I take up this thing, what a class is, a user defined data type. Fine. I'll take up the word. What is actually this data type? Yes. Fine. I think you people have already heard so many number of types, the data type, the data type. So this data type, actually, it represents a kind of value which determines what operations can be performed on data. Fine. So what type of operations can be performed on data? It is always represented by the data type in any programming languages. Whether it can be, your data can be either an integer, or it can be a floating point, it can be a character, it can be of Boolean type, or it can be of string type, and so on. So what type of operation has to be performed on the data, that is always specified by using what? The data type. Fine. Now coming to this, you have already studied or encountered several objects, okay, like string, list, tuples, dictionaries, and even numbers in Python, which can be considered as an objects. Fine. So whatever you have studied till now, either it is a list, or it is a string, or it is a dictionaries, or it is a tuple, or some numeric data type, all can be considered as a standard or a built-in data types of Python. Fine. So they are all standard and they are all built-in data types in Python. But coming to this class, you can see here a class is a user-defined data type. Fine. When it comes to the user defined data type, your class is also a data type, okay, which can perform like a list, a string, fine, once again a dictionary or a tuple, but it is always defined by what? A user. It is nothing but by us. Fine. This is not a standard or a built-in data type. It is a user defined data type. Fine. It is nothing but we are going to define a data type that can be considered as what? A class. Once again, what actually this class does? It binds both the data, fine, on which the operation is performed. Data is nothing but we need a data whenever we want to perform some operation. Binds the data and functions together into a single entity. So whenever you take object oriented programming, fine, attributes, and functions comes into existence. Attributes are nothing but the properties. Once again, the functions are nothing but it can be considered as a behavior or your methods. Fine. So that is how actually a class is defined. A class is a user defined data type. Example, I'm considering here a point as a coordinates, that is x and y. Fine. So as I already told, there are various types of built-in data types in Python. Now, if I just take a point which has a coordinate x and y, suppose consider I want to plot that particular point. Fine. So this is your x coordinate, if I just take an example, and this is your y coordinate. Fine. So if I want to consider, suppose I consider this is a point that is represented in a graph, okay, in a plane, then once again I think x coordinate consider some value of x here, something like 5, and this is something like 6. Now if I want to store the coordinate values of this point, fine, if I just consider the standard built-in types that are present, I can consider two variables, one is x, one is of y, of integer type, store the value of x something like 5 and store the value of something like 6 to y. So it is nothing but I'm using the basic data types and storing those values to these two variables, that is x and y. So this is a standard or a built-in that is existing. Now once again, if I consider a list, suppose I'm plotting just a single point. If I want to plot, okay, once again plot more than one number of points. So what I can do, I can use one more data type. Okay, if I just use a list, I can use a list for x to store the x coordinate values. Okay, and once again I can use one more list to store what, the y coordinate values. Once again, what, this is already existing, this is built in. Fine. Again, if I want to take up one more, I can also take tuples. It is already a built-in. Take a tuple, okay, and store all the x coordinate values. Take y as a tuple and store all the x coordinate values. Fine. So these are all already present, they are standard and they are built in. But what we are going to do is we are going to define our own data type, which is called as class. Fine. Either it can perform like a list or whatever it is. Fine. So we are going to define our what, the own data type, fine, that are called as what, a class. So we'll be studying all about what, the object oriented concepts. Now we saw what actually the class is, how actually we are going to assume what actually the class is. It is a user defined data type. It will be complex because since we are defining a class, more of the operations has to be once again incorporated whenever we are defining a class. And after defining the class, what all the other things we can do, okay, we should check with all those things. But once again, it has got both advantages as well as disadvantages. Fine. Now moving to the next. Now if I just see here, a class is just a prototype. Fine. You can see here, class is a user defined data type. I can also consider a class is just what, a prototype or a logical entity, or it can be considered as a blueprint which will not consume any memory. Fine. Till now I'm just talking about only these classes. I have not just touched with any of the objects. Just a class is what, a user defined data type, or this class can be considered as just a prototype, or it can be considered as a blueprint. And one more thing is, it will not consume any memory. Class does not consume any memory. It is nothing but it is just a prototype, or it can be considered as a logical entity, not the physical entity, because it is not existing physically by consuming the memory. Or it can be considered as what, a blueprint. Fine. Now a class is defined, once again it is a user defined data type where we are going to define the class. Now if I want to just take this statement and just if I just take an analogy to represent what actually this statement is representing. Fine. Suppose you consider house construction has to be made. Fine. Now before the house construction has to be made, what we need to do is we require what, a plan. Fine. So a plan is made before the construction of house. That is nothing but the architect plan or the drawing is made where on a paper. Fine. A plan is once again made before we construct any house on a paper. Now here, fine, when I just tell that this plan, this plan is not consuming any land area. Fine. Similar to this, your class is not consuming any memory. Fine. It is just what, it is just a blueprint, or it is just a diagram or a design that is telling that the house has to be constructed like this. Fine. So once again, when I consider this plan, your plan does not consist of only a piece of paper with just telling what this is 40, 60 side. Fine. But instead, your plan also tells that, fine, where actually, okay, the door has to be fitted, the windows has to be fitted, what is the area of the room, what is the area of the kitchen that has to be made. Everything in detail is discussed or it is once again put on the plan. It is just a blueprint, fine, where I can make this analogy with respect to what that is class. Fine. It is not going to consume any land area, which is similar to that. It is not consuming any memory. It can be just considered as what, a prototype or what, or something like a blueprint. And once again, a class consists of what, both the attributes as well as the function. Attributes are nothing but the properties. Yes, definitely when we consider the plan on a sheet of paper, definitely there are so many properties that can be represented. Windows, once again the doors, once again the rooms, etc. Those represents the properties, or some methods or the behaviors. So where I need to enter, which side I should take a turn to enter the room, everything is represented where, on the plan. Fine. So that is how an analogy can be made with respect to this example for the class. Fine. Now, when I take this, a class is just a prototype or a logical entity or a blueprint which does not consume any memory. Then what is an object? Fine. So what is an object? When I construct the house, okay, by using this plan, that house becomes an object. Fine. Now I have a single plan. By using this plan, I can construct n number of houses. Suppose for an example, villas. Fine. The same type of houses will be constructed more than one houses. See, the same plan, I can construct n number of houses. It is nothing but by using a class, I can create an object. Fine. The constructed house is an object. Where the house is constructed, on the land area, it is nothing but it is occupying what, a land. It is nothing but the object consumes memory, or the memory is allocated to the objects, whereas the memory is not allocated to the classes. Fine. The constructed house, fine, it is an object. By using a same class, I can construct how many objects? More than one objects. In the similar way, by using a single plan with a good architecture, I can construct n number of houses, where I can make an analogy with respect to the objects. Those houses, they are constructed on which one? On the land. It is nothing but they are consuming the land area, whereas the class, it is not consuming the land area. It is just what? It is on a paper. Fine. So that is how the class and the object are differentiated. Your class will not consume any memory. Your objects consumes memory. Fine. Now taking this, fine. Now coming to the objects. An object is an instance of the class and it has physical existence. Fine. Whereas a class is just a prototype with a logical existence. Coming to this object, an object is an instance of class and it has what? It has a physical existence. It is nothing but it consumes memory, whereas class does not consume memory. How the object is created? Class creates what? The object. When the class creates an object, it is an instance of the class. It is nothing but what? Just a representation of what? That is a class, but with some memory allocated to that particular object. Fine. So that is how I can differentiate between a class and an object. So here the objects are created out of the class. Fine. And object can be considered as an what? An instance of the class, and it has got a physical existence. Fine. One can create any number of objects for the class. As I already told, an example of the housing plan and the construction of the houses. With a single plan, I can construct n number of houses. So it is nothing but if I have a class, okay, one can create how many number of objects? One can create any number of objects. It is not a single object that will be created from the class. Fine. So this class will be having some properties, some behaviors or the functions. So everything can be used by these objects. Fine. It is not only so that whatever the properties or the attributes and the functions or the methods that exist in the classes, only that has to be used by the objects. It is also possible that an object can once again create its own properties as well as what? Methods. For an example, suppose using that plan, I have constructed what? This house. But similar, consider there are two houses. This is exactly constructed as a plan. Fine. here coming to this house, it has once again, okay, incorporated all the features of the properties that is existing in the plan. But here what I want to do is I want to include one more floor. Fine. So for this object, I can once again add that particular floor. It is nothing but I can do the modification for these objects. Fine. I can also use all the properties and the methods that is existing in the class. I can also use what, okay, modification to what, these individual objects. So one can create any number of objects for a class. So your object is nothing but what, an instance of a class. It is created by a class. Fine. And one can create any number of objects for a class. Now, coming to this, a class can have a set of variables. Your variables are nothing but the properties or the attributes. I think when you people have studied DBMS, you have come across the word attribute. Your attribute represents what? The properties of the entity. Entity is nothing but what? It is an object that exists in real world. The same thing has to be compared with respect to the classes and objects. Your variables are nothing but it represents the attributes. The attributes are nothing but the properties. And once again coming to this member functions. If some functions are defined within the class, okay, these variables and members are defined within the class. They are known as member functions. They can also be considered as what? Methods. So these methods, they represent the behavior of the class. Fine. So that is how we can just differentiate between the classes and the objects. Now, coming to this, fine. Now, in Python, fine, a class can be created by using the keyword that is class. Fine. So in Python, a class, it is nothing but a prototype or a template, can be created by using a keyword by that is class. And okay, here we'll see how to create a class, but we are creating an empty class. Fine. You can see here I'm using once again the keyword class, followed by the name of the class I'm taking is what? A point. That is representing x coordinate and y coordinate point. Okay, that is followed by colon and followed by pass. Here pass is nothing but a keyword. Okay, that is just telling we are not doing anything within the class. Fine. Now once again when it comes here class followed by point, you can see here whenever I'm just giving the name of the class. Fine. Class is a keyword that has to followed by the name of the class. The name of the class I'm considering here, it is called as point. Fine. Now it is always we'll see to that it is not mandatory, but whenever we are giving the name of the class, we'll follow some nomenclature. Okay, like this, like where the first letter of the class name is always given in the capital letter. It is not mandatory, but it is a standard way of defining the name of the class. Fine. Where the first letter of the class name is always given with respect to what? In capital letter. And this is the keyword class. So whenever I'm defining it, I have to define by using a keyword class. Here I'm not doing any operation. Neither I have declared any attributes within the class or any methods of the function within the class. Just I'm creating a class by the name that is point. Fine. Now when I'm just printing what actually this point is, print followed by what, that is point, you can see the output something like this. Okay, so this is representing, this is a data type. What is a type now? It is a class. Fine. And once again coming to this point, it is class. It is nothing but it is something like the main function. Whenever you write C programming, int main so and so, so it is something like what, it is main. What is the name of this main? That is your point. Okay, the type is what, that is class, and once again it is representing as the main. Okay, and what is the name of the class? That is point. So this is what you can see whenever you just create a class using the keyword class and just print by using, this is your class name. Fine. You can give any class name here. So this is your class name. Just give colon. Once you press enter, once again there will be tab space with 4 spaces here. Exactly here you will define the variables or your methods or the functions. In this example, okay, it is an empty class. Now, user defined data type point got created. Okay, and this can be used to create what? Any number of objects of this class. Fine. Now class is created here. So after creating a class, what we can do? Fine. We can, a class is defined. We can create objects by using this class. Fine. Now, once again, what is one more important difference? This is the logical existence, whereas object is physical existence. Logical existence in that turn, it does not consume any memory, whereas object consumes memory. Fine. Now, how to create a object? Fine. Now, your point you already know it is what? It is a class. Fine. Now, this object, consider any object, it is an instance of the class. It is nothing but it is an exact copy of the class. So here, okay, so an object can be created by using this. Here whatever I'm taking here, P, it is an object, fine, that is created. Okay, this point is what? A class name. Fine. So here P is an object, or it is an instance of the class. What is the class? That is point. Fine. So already this class is defined. So once again, give the name of the class with opening parenthesis and the closing parenthesis equals to P. Fine. It is something like, whenever you take something like Z equals to, okay, if you just use, okay, list, what it will happen now? Fine. So whenever you just tell what is the type of Z, it is going to return list. Fine. I told your list is what? A built-in data type, and it is a standard one that is present in library. Now your point, it is what? It is a user-defined data type where we have defined, and I'm defining. See, a similar way, you are creating a list object here. Z is what? A list object. In the similar way, here P is what? It is a class object. Fine. So here list. So once again here P. So your object, your class creates object. Your object is nothing but what? An instance of the class. So here your P is what? An object. Fine. Similarly, I think dictionaries also, you give Z equals to dick. Fine. Or tuple, Z equals to tuples. Fine. That time Z will be what? A tuple object. Fine. Here P is an object. Fine. That is user defined. That is once again what? Created by using user defined. That is your class. Now, a reference to a point object is created. Whenever we just give this statement like this and execute it, what will happen? A reference to a point object is created and it is returned. Reference to a point object is nothing but what? The memory is allocated. It is nothing but that object, fine, is consumed with memory. So a reference to a point object is created and it is returned. This returned reference is assigned to the object what? That is P. Fine. So the process of creating a new object is called as what? Instantiation, and the object is what? An instance of the class. Instantiation, and the object is what? An instance of the class. Now whenever you just type this statement and execute, okay, and just you print this P, you can see the output similar to this. Fine. You can see here when we just printed what? Then along with the class name, you was supposed to see the type was what? The class, and that was what? The main. And once again, it has not been once again returned with any value similar to this. Fine. Whereas when I'm printing P here, your P is what? An instance of the class, that is your object. So what it is doing here? It is an object of which one? Of the class point of what now? It is of main. Fine. So main, once again the class name is point and the object. So the type of P is what? An object add. So a reference of the point is created. This is nothing but the address of the memory location of this object. Fine. So here object is consuming memory, whereas the class is not consuming memory. Okay, coming to this. Fine. An object can contain named elements known as attributes. Fine. Now when I started with the class, fine, so your class can consist of what? Attributes as well as methods. Fine. So whatever the attributes of the properties and functions are defined along with the class can also be used by what? The object, because this object is nothing but an instantiation of the class or an instance of the class. Fine. Upon that, whenever the objects are created, as I just gave an analogy with what? Okay, some plans are constructed exactly, some houses are constructed exactly as the plan, and some houses where something like, okay, I want one more extra floor to be in built, okay, then I can do addition to that particular object. It is similar to this. An object can contain named elements known as what? Attributes. Fine. Now one can assign the values to these attributes using the dot operator. Fine. For example, if I just the coordinate points, I have both x coordinate as well as the y coordinate. Keeping the coordinate points in mind, we can assume two attributes, that is x and y, for the object P. How to create an object? We have already seen P equals to point with opening parenthesis and closing parenthesis of a class point. So whenever you are creating, or whenever, okay, you are creating an attributes, okay, for an object, then that has to be done by using the dot operator. Fine. Here P is an object, X is an attribute. This attribute is created for which object? For the object P. Fine. And assign the value. What is the value? That is 10. Once again, this is an attribute or a property that will be only associated for which object? That is for object, that is P. And that is done by using what? The dot operator. P dot X equals to assign some values. P dot Y equals to assign some values. It is something like I have a class. So this P is an object, fine, which is nothing but an instance of the class. So this P can consist of its own attributes X and Y, assigned with the value 10 and 20. When you just print P dot X, you can see, okay, 10 will be printed. When you just give print P dot Y, then you can see 20 will be printed. Okay. Now, only keeping the concepts of the classes and the objects, fine, we'll take up this program. We are not going in depth today. We are not going to define any variables or the methods within the class. Okay, so whatever the declaration we are going to make, everything will be done outside the class, but the objects are created by using the class. Fine. So what we need to do is we need to write a program, class point. Okay, the class, what is the name of the class? That is point, representing a point on coordinate system. Implement the following functions. Now these functions are not defined within the class. Okay, in tomorrow's class, we'll take up this and we'll see how the functions can be defined within the class and how that can be used by the objects that are created by the class, which are an instance of the class. A function, what is the function I need to do? Read point to receive what? X and Y attributes of a point object as an user input. A function distance, which takes two objects of point class as arguments and computes what? The Euclidean distance between them. A function print point to display one point in the form of ordered base. And this is what the Euclidean distance is all about. Fine. It is nothing but there exist 2 points. I need to find the distance between those 2 points by using what algorithm now? That is your Euclidean distance algorithm. So here the Euclidean distance is given by using what? Square root of x minus a of whole square plus y minus b of whole square. Fine. So this is the x coordinate of the first point. This is the x coordinate of the second point. This is the x coordinate, y coordinate of the first point. This is the y coordinate of the second point. We need to use this formula. So how many functions we need to write? We need to write 3 functions. Fine. And once again, we want to perform by using what distance formula? That is your Euclidean distance formula. Fine. We'll take up this program. Okay, we'll take up that example. So the Euclidean distance is what you are supposed to do. Fine. Now before this, fine. So let's define a class. I'll take a class defined with the name that is point. So that is the name of the class. Okay, just a second. Okay, the class, just give colon, then I'm not defining anything. I'm just making an empty class. Just give pass. Okay, now print. Okay, just provide the name of the class and check what it is showing. You can see the type is a class. Then once again, it is of main type. And what is the name of the class? That is point. Fine. So here a class is defined. Fine. After defining the class, now I want to create an object of this class. Now how to create an object? Create an object by using, if I consider P is an object, equals to of what type? Of point type. P is an object of what? That is point type. So once again here I need to make it as what? That is point. After this just give print, okay, and check this object. So this is an instance of what? The class. So your P is an object. So once again just what? Just run this and check. You can see here it has been allocated with the memory. So this is of the address of the memory location for which one? For the object P. Fine. You can create one more object. Consider P1 equals to. You can also create one more object. Okay. Once again, if you want to just give print of P1, again you can check. Okay, so this is one more address location. Fine, you can see the address location of this is different and this is different. Fine, like this you can create, okay, any number of objects, okay, by using this class. So these all objects are your instance of what? That is your class. Fine, so coming to this class, it is just what? It is a logical entity or it is just a prototype, but this is your user defined data type. Fine, in now coming to that, once again, now if I consider this point P, fine, if I want to define the attributes or the properties associated only for what? The object. I'm not defining any attributes within the class or the functions right now. Just I'll define or declare some attributes for the object. What is the object now? That is P. Now if I do, okay, I want to once again define two attributes, x coordinate, that is coordinates of the point x and y. One is variable x, I'll initialize with some value, that is okay, 10. Then once again y with 20. Fine. Now I want to once again define for which object? For this object. So just give the name of the object along with the dot operator, then just give P followed by x. Fine. Now just you can run this, okay. Then if you want to just print, okay, print the value, that is P dot x comma P dot y. You can do it separately also. Just run it. You can see, okay, it is an object type. The attribute values are 10 and 20. That is what is what. Now if you just give here, okay, since if you assume that already x and y is declared, so I can use P1 dot just print, okay, P1 dot x. Fine, it is going to give an error telling that point of object has no x attribute. It is nothing but that attribute is not defined for which object now? The object P1. Fine. So this is how we can create objects from the class. Now we'll take up that example where we are going to just what we are going to do. We are finding the distance by using the Euclidean algorithm. So they are told that we need to once again define three functions for reading the data. Once again, what? Finding the distance, a separate function, as well as printing it. Fine. Now we'll start with this. Now they have asked that we should define what? A class with the name point. So just define class with the name point. I'm not going to do anything, just pass it. Fine. After that, what they have told now, we need to define, okay, to read a data, a separate definition for reading the data. It is nothing but for reading the points of x and y coordinate. Fine. Now since we are using the Euclidean distance, we need to once again find the distance between 2 points. It is nothing but for first point I want the x coordinate value and the y coordinate value. For the second point also I want x coordinate value as well as the y coordinate value. I'll start with defining it. So define, okay, that is to define a function. So def is the keyword that is used to define a function. I'll take the name of the function as, okay, read point. This is the name of the function followed by colon. Fine. Now in this I'll define x as a variable where I need to input the coordinate values. Fine. So I'll take, okay, float, fine, of input. What is the input I need to do? I need to read the first x coordinate value. So enter the x coordinate. Similar way, what I need to do now, y equals to once again float. So once again input to do now, enter the y coordinate value. Fine. So I've taken two variables, one to input x coordinate value, the second one is to give the y coordinate value of a point. Fine. After that, okay, what I need to do? Okay, I have defined a class. Fine. There are 2 points. I need to use what? Euclidean distance. Fine. Now, one point, okay, I'm going to represent by using one object. The other point, it is represented by using one more object. So what I'll do now, I'll create an object P1, fine, where this object, it is going to read the x and y coordinate values for the first point. Whereas I'll create one more object P2 where it is going to read the x and y coordinate values for one more point. So P1 I want to make it as an object of the class, that is what? Fine. In the similar way, I want to just create one more object. Okay, I'll take it as P2, where once again I'm just making this P2. It is an instance of the class point, and I'm creating one more point. Fine. Now I need to read the values of x and y coordinates of this point by calling this function. And again, once again, read the values of the x and y coordinates of the second point by calling which function? The function that is def and read underscore point. So what I'll do, I'll just give print, okay, enter coordinates of the first point. Fine. In a similar way, I'll copy this and I'll give this. Okay, enter the coordinates of which one now? The second point. I'll take it as the second point. Fine. Now after that, I need to call which function? I need to call this function. Now call this function read underscore. Okay, what is the name of the function? That is point. Fine. Again here, call this function read underscore what? That is point. Fine. Now I'm calling this function, fine, but I need to have the values that is x and y. So I need to once again provide the argument for this function. Whenever I'm calling, I need to give the arguments. Fine. So the argument for this function is I'm passing the object as an argument. Fine. Again, I'm passing this an object of the I'm passing object as an argument to this function. Now this P1 and P1. So here once again when I'm passing this object as an argument here, okay, I should have some formal argument to replace with the actual argument. Whenever you are specifying the argument during the calling a function, this is called as actual arguments, whereas this is your formal arguments. Fine. So this is the actual, this is your formal. Now when I told, whenever you want to once again declare a variable within the object, it should be always done by using what? A dot operator. Okay, something like what? It is p dot x, fine, or something like what it is p dot y. Now here, whatever p1 here, it is an object. It is of type object. Whatever p2 here, it is of type object. Now I'm passing this object as an argument here. Fine. Now if I pass here an object as an argument, it will be using these two variables. Once again what? By the object. So I should give it as what? P dot x. Once again here what? P dot y. Fine. Now whenever this function is executed for the first time, what will happen? This is the actual argument that is passed here. Fine. So it will just enter into the definition. This p will be replaced with P1, this P will be replaced with P1. So your P1. Yes, anyone has switch on the mic, just switch off now. So coming to this here, this P will be replaced with P1 and again P will be replaced with P1. So whenever I call this particular function, fine. So again this one, now just run this and we'll see whether it is taking 4 values. Run this. So enter the coordinates of first point. Fine, I'll give 2, then once again 3. Enter the coordinates of second point 4 and 5. So whatever I've written the program, it is doing the operation up to there. Fine. Now after entering these coordinate values, now I need to find the distance. So the distance has to be once again calculated by using what? The Euclidean distance. The Euclidean distance is given by the formula what? The square root of, okay, coordinate of x coordinate values of both the points, that is x1 minus x2, then once again y1 minus y2 the whole square with what? The summation operation. So if I just give, I'll write what? D equals to, okay, I'll write the formula square root of, fine. So after writing the square root of, I'll just tell thing. So here how many attributes have now? P1 dot x, P1 dot y, P2 dot x, P2 dot y. So I'll give P1 dot x, fine, minus P2 dot x, fine, whole square. So it is nothing but, what is the formula we'll be using, or the operator? It is nothing but 2, fine, to the power of 2. Then plus again, okay, P1 dot y, fine, minus P1 dot, sorry, P2 dot y, again the square, that is with square, fine. So this is the formula that we are using, square root of, okay, x1 minus x2 whole square plus y1 minus y2 the whole square is your Euclidean distance. Since I am using your mathematical function, your square root, fine, we need to import what package? So import, okay, the library, that is math, fine. After importing the library math, I need to prefix this here. So D equals to math dot square root of P1 dot x minus P2 dot x star star of 2 plus P1 dot y minus P2 dot y star star of 2. Fine. I'll print and check whether I'm able to print the distance. Then I'll define that as a function. So this is the formula. So just run it. Okay, enter the first coordinate. I'll give 2, then 3, then again 4, 5. So it is calculating the distance. Fine. But in the question, they are told that I need to define this distance as a function. Fine. Now just define this distance as a function. So once again, I'll give def. That stands for definition. I'll give the name of the definition as distance. Then followed by, okay, I'll give an colon. Then immediately followed by this, what it is? D. Fine. I need to return the value. So return what? The value D. Fine. So after defining the distance, after reading the point, since it is defined as a separate function, I need to call this distance. So call this distance. Okay, after calling this distance, whatever the value that is returned by using this function, I am going to store it in a separate variable, that is dist variable. Fine, distance and so on. Now I need to again pass the parameters, fine, or the arguments whenever I'm calling what? The function distance. So what are the arguments I need to pass? Again, I'm passing the object as an argument. What objects I'm passing? When you just see here, I'm using object P1 for which variable? X variable and Y variable. Again, object P2 for which one? X and Y variable. So I'm passing an object as an argument. So first object P1, second object P2. So whenever I'm calling a function with this actual arguments, then again here also to catch the values of this, it has to be defined here. So again P1 comma P2. Fine. After this, just what? Okay, this D will return a value. After returning this, okay, it will be stored where? In this variable. So just display the value of distance. Fine. So if I just display it, just run it. Again, I'll give 3, then 4, then once again 2, then 5. Then you can see the, okay, the distance value is what? That is 1.414. Fine. So I have defined two functions. One is read function and the distance function. In the similar way, okay, you people need to define one more function to print, okay, the coordinate values as well as to print what? The distance. I think you people are able to do that by defining that particular function. Fine. So what we are taking from this example is, fine, we can also define the variables and the functions outside the class. Fine. And whenever we are defining or whenever we are creating the objects, we can pass these objects as an argument to the function and perform the operation. fine. And once again, with respect to the objects, fine, and individual objects can also have its own variables or the attributes or the properties. And even, okay, and objects can be related to other objects. One object can be related to other object, or one object can be in connect with other object, once again through the messages. So whenever an object is sharing some of the properties to the other object also, it is possible, which is called as inheritance, which is the one more important concept in object oriented programming. Fine. So right now in today's class, we have not defined any variables and functions within the class. We have just done everything outside the class, but we have seen how to define a class, how to create an object, fine, how to assign a values or the variables to the object, fine, how to print the values of the variables of the project, and how an object can be given as an argument whenever we are doing a function call. Fine. So you can include one more function to this, where it is going to print the values of both the x and y coordinates of both the points and the distance. So whenever you are printing the value of distance, you have to call that print underscore data. Okay, so that will print the what? The distance value. And along with that, you need to print the coordinates of both the points, that is x and y coordinates of point 1 and point 2. Hope so that I think you people are able to do it. Fine. So this is what all about for today's class.